This is one possible way to write it. I wish to write it another way since we wish to take yet another derivative. What I write it another way is this is going to be, I'm going to go back to this line. This equals negative 1 times x squared plus 7 to the negative 1. This is the half exponent, this is the negative 6. This is the negative 1 times x squared plus 7 to the negative a half. This equals, sorry, I left the x out. There's an x right there. Equals, I'll just write negative x times x squared plus 7 to the negative 3 halves. So I'll leave it as an exponent like that. X squared plus 7 to the negative 3 halves.
Can you just elaborate real quick on how that went down while we're still rolling?
Yes. Fine. There's two ways you can look at it. You can say this is a half, and this is negative 2, because it's a tower of exponents you multiply and get negative 1. I can just look at this right down. This is x squared plus 7 to the negative 1 power, because on the bottom, x squared is 7, negative a half power. So it's negative 1 power, negative a half power. You multiply two numbers of the same base, you add exponents, negative 3 halves.
Beautiful.
And we want to continue with the second derivative. I'm going to say f double prime of x equals. Well, I'll just record, this is a more complicated thing. I'm going to call this piece right here, I'm going to call this thing now u. This thing I'm calling u. And this thing over here, I'm going to call v. Calling this thing right here v. V. So we're going to find u prime and v prime. And the rule is it's u, derivative is u, v prime plus v u prime. If u is negative x, so u is negative x, that's what u is. Right here we'll put v prime. Here we'll put in v, which is x squared plus 7 to the 3 halves. Here we put in u prime. U is negative x, u prime is just plain negative 1. Right here we have to put in v prime. In this blank we have to put in v prime. V prime will be hard to produce, so we're going to use the chain rule again. We're going to use color. V equals, I'm going to use another color now. V equals W to the minus 3 halves, to the minus 3 halves. But what was W? W was equal to x squared plus 7. So V is W to the minus 3 halves. Now how do you find V prime? V prime is going to be equal to this derivative, minus 3 halves, times W, subtract 1, minus 5 halves, times W prime. What is W prime? 2x. So this equals 3 halves, W to the minus 5 halves. W prime is 2x. This 2 and this 2 cancel. I'll continue over here. Moving the x in front, I get 3x W to the minus 5 halves. And we put in what was W? W was x squared plus 7. So I have 3x times x squared plus 7 to the minus 5 halves. This is what V prime is. I'm putting all this into this blank over here, because that is what V prime is. So remember I had to do two tricks. First I looked at this function as a product of u and v, and I used my product rule over there on the extreme right. Then to find v prime, I use the chain rule. I define v to be w to the minus 3 halves, where this was w. This was v, and this is w to the minus 3 halves. Often something in parentheses should be given another letter or another name. We took v prime, we got this derivative here, minus 3 halves minus 5, w to the minus 5 halves times w prime. We substituted in w as x squared plus 7. We found w prime was 2x. We simplified, we got this. This is v prime. I'll put it in here. We got minus x times 3x times x squared plus 7 to the minus 5 halves minus 5 over 2 plus x squared plus 7 to the minus 3 halves times minus 1. So the same times minus 1, I'll just subtract it. I'll just write this here and erase this minus 1. That is going to be the derivative f double prime. Let's simplify a little bit. This equals minus 3x squared. Put this on the bottom. X squared plus 7. The square root of that, all raised to the 5th power. Minus, this was 3 halves. 1 over x squared plus 7. Square root of it. The 2 means square root of it. The 3 means I raise it to the 3rd power. And this is going to be the second derivative. Now that we have the second derivative, we go ahead and plug in 1 to find f double prime of 3, so we change x to 3. Changing x to 3, I get as follows. F double prime of 3 equals minus 3 times 3 squared all over the square root of 3 squared plus 7, square root of that to the 5th power, minus 1 over square root of 3 squared plus 7 to the 3rd power. Now 3 squared plus 7 is 9 plus 7 or 16.
To the 3rd power.
I'm sorry. Thank you for the correction.
That's right.
Cameraman, thank you. This is 3rd power. So this equals minus 27 over the square root of 16 to the 5th power, minus 1 over square root of 16 to the 3rd power. Square root of 16 is 4, so it's minus 27 over 4 to the 5th power, minus 1 over 4 to the 3rd power. So 4 to the 5th power is what? Well, 4 to the 5th power is 4 times 4 times 4 times 4 times 4 times 4. This is 16 and this is 64. Multiply 16 times 64. We get 16 times 64. 64 times 16. 24. 24. 36, 38. And 64. Get 12. 1024. So this is minus 27 over 1024. 24. Minus 1 over 4 cubed is going to be 64. I multiply this by 16 over 16, so in both cases the denominator is the same. We have to move way up here just to have a little room. We're going to have 27 over 1024 minus 16 over 1024. It's going to be 11 over 1024. That is the final answer.
If you were doing it without a calculator.
Yes.
Right. All right. Yeah.